All right, polynomial division. We're going to use the CPM method of polynomial division. So we want to start off by writing out a rectangle, just like this. And then you want to take your divisor, which would be m plus 4, and we want to put that on the side of our rectangle. And then the next step would be to take your leading term, which is m to the 4th, and place it in the first box. Now, before I go any further, I do want to ensure that because it's a 4th degree polynomial, and we know that because the largest exponent on the leading term is 4, that we have an exponent of a term with an exponent of 3, 2, 1, and our constant, which we have all the terms. There's no missing terms, and so we don't need any placeholders. And you'll see what I mean more about that in the next example. Now, this is a rectangle type problem or a square problem. And what I mean by that is that we can multiply the sides of the boxes to get the area of the inside box. So m times what is m to the 4th, or if you want to take m to the 4th divided by m, then we would get m cubed. And so since the top of the box is m cubed, we're going to multiply it by the bottom left, which is 4, and get 4m cubed. All right, so our next box, which is on the diagonal, okay, so our next box, or this box here and this box here on the diagonal, are going to have a sum of our next term, which I have highlighted. And so 4m plus 4m cubed, gives us an 8m cubed. And again, the top of the box is going to come from 4m cubed divided by m, or what times m is 4m cubed, and that would be a positive 4m squared. And so since the top of this box is 4m squared, we can multiply it by the 4, and we get 16m squared. All right, so our next term is 18m squared, and so our next diagonal is what we're looking for, to be 18m squared, and to get that we need a 2m squared. And so if the inside box is 2m, m times what is 2m, and that would be another 2m. So 2m times m is our 2m squared. And since the top is 2m, we multiply it by the 4, and we get 8m. All right, and then our next terms in the polynomial is 13m. We notice here on our diagonal, we need a 13m, and so 8 plus what is 13? 5m. And so m times what is 5m? That would be a positive 5. And 5 times 4 is 20. And so our last term is 20. And so on the diagonal here, we get a 0. Okay, and so that means we have no remainder. That means that m plus 4 is a factor of our original polynomial. And so the way we write our answer out is that m cubed plus 4m squared plus 2m plus 5. Okay, now in our next example, we're going to need to rewrite this first. If you notice, we have a 3rd degree polynomial. We know that by the leading term because these are in standard form. And I have an 8r cubed, but I have no r squared. And so we're going to want to add a 0r squared. The 0 in front of the r squared negates the fact that we've added this to the equation. And so then we can just go ahead and copy our negative 8r down, and then negative 10. There was no other missing terms. And there's times that you may have multiple missing terms that you need to put a placeholder in. All right, so we draw our area model, place our divisor, r minus negative 1, on the side, and then we're going to take our leading term, which is 8r cubed, and plug it in. Now, 8r cubed divided by r is 8r squared. And 8r squared times -1 gives us a -8r squared. All right, and so our next term after the leading term is 0r squared. So this diagonal here is going to give us a 0r squared. If we already have a -8, then we want a positive 8r squared to make the 0r squared. And then 8r squared divided by r is a positive 8r. And 8r times -1 is a -8r. All right, so our next term is -8r, and we have a -8r here. So on this diagonal, we need it to add up to -8r. Well, if you already have your -8r, then you want to add 0 to it to keep it the same. And so r times 0, or 0 times r is 0. And 0 times -1 is 0. And your last term is -10. Well, we have a 0 here on our last term, and on our diagonal, we need a -10. All right, so let's think back to our early days in school. Let's say we had the problem 39 divided by 3. You'd ask yourself, 3 times what is 3? And you'd say 1. And so you put a 3 and you subtract and you get it 0. And then 3 times what is 9? You'd say 3. And you drop a 9 down. We drop our 9 down, then you would subtract the 3 times 3 is 9, and you get 0. And since you had already gone through all your terms, you would have no remainder. We know that 3 is a multiple of 39. But let's say we had 40 divided by 3. So 3 goes into 4 one time. We subtract that, we get 1. You drop the 0. 3 goes into 10 3 times. We put down a 9, we subtract, and we get 1. Well, what this meant is that we had a remainder of 1. And then eventually you were taught that you can write that as 13 plus the remainder over your divisor. So 13 plus 1/3, and since those are like terms, we can say 13 and 1/3. So in a similar fashion, over here on our problem, we have a remainder of -10. And so the way we're going to write this is 8r squared plus 8r. Now, the remainder was negative, so minus 10 over our original divisor, which was r minus 1. And so this is the result of dividing our polynomial by r minus 1. And since we have a remainder, similar to how we first learned to divide, if you have a remainder, then what you're dividing by is not a factor or a multiple of what you're dividing. All right, let's move on to the next example. And so in this example, again, we're going to start our box for the area model. We write our divisor down on the side. So 4r minus 3. We put our leading term, 4r cubed, and quickly check you have a degree 3. You have your degree 2, 1, and 0. So we don't have any missing terms. So we can go ahead and determine what times 4r is 4r cubed, and we get r squared, and r squared times -3 is -3r squared. And so again, we'll highlight our next term, 5r squared. We start with a -3r squared, and so -3 plus what is 5. Okay, so we're going to get an 8r squared, and 4 times 2 is 8, and we need an r to get our r squared, and then 2r times -3 is -6r. All right, and so then our next term is -10r. We have a -6r already, and so again we need to find the sum that gives us a -10. And so we want a -4r, and 4r times negative 1 is a negative 4r, and negative 1 times negative 3 is a positive 3. And so on our next diagonal, we see that our next term being 3, we already have our 3, and so our last number here is a 0, meaning that we have a remainder of 0. So 4r minus 3 is one of the factors of our polynomial, and so r squared plus 2r minus 1 is our solution. All right, one last example. All right, so again, we draw our box. We want to put our leading term, 5n cubed, in the front. We want to place our divisor on the side of the box. And then, again, so 5n times what is 5n cubed? And it would be n squared. So we want to find our next term, which is negative 2n squared. And so these here will give us our next term, and I guess we need to figure this one out. So it is a negative 5n squared, and we have negative 30n squared, so I need a negative 25n squared. And 5 times negative 5 is our negative 25, and n times n is n squared. And so negative 5 times negative 5 is 25n. Our next term is positive 40. So we need this diagonal here in yellow to give us a positive 40. And so we want to use a 15n because 15 and 25 is 40. And 5n times 3 is 15n. So we are end with a negative 15. Our next term is negative 17. So our diagonal, we want us to get a negative 17, which means we're going to finish with a negative 2. So being that we're on our last term, that means that we are going to have a remainder. So again, our answer is n squared minus 5n plus 3 minus, because the remainder was a negative number, and we just leave it as a positive 2 with the negative out in front, and then our divisor was 5n minus 5. All right, guys, I hope this video helps.